In this video, I will show you how to use a triple beam balance to measure an object's mass. So here is a picture of a triple beam balance. I'd like to point out several features of this balance. In this area, you have your pan where you'll weigh your object. This area right here is the scale where you'll eventually move the weights to get the mass of your object. Then there's two more special areas on this. This section here has the pointer, and then on the other side here is the knob to control the level of the pointer. In the next few slides, I'll show you how to use the scale and how to adjust the pointer using the knob. Okay, here's a close-up of the scale. Now we call this a triple beam balance because it has three beams. This beam here controls the 100-gram weights. This beam here controls the 10-gram weights. And this beam here controls the 1-gram weights. One thing to note, it's very important for these two weights to be in their little notches whenever you're taking a measurement. Right now, the scale is reading 0 grams for the mass. On the previous slide, we saw all the weights set to 0. Now in this slide, we're going to look at this section here, which has these two lines. This here is telling us if our triple beam balance is actually level. These two lines must be aligned in order for this balance to be level. How do you get these two lines to be aligned? Over here you have the adjustment knob, which you turn clockwise or counterclockwise until the two lines are aligned. As a little side note, the beam has a damper which quickly kills out any oscillation of the beam. The way that it works is this metal plate here actually travels between two magnets, which generates a force on the plate, causing it to quickly come to rest. Here is a video clip showing this. In this slide, we measure the mass of a wooden block. But before I show you how to measure the mass of this wooden block, I need to point out the following about the 1-gram scale. When you look at the smallest unit of measurement on this scale, you'll notice it is 1/10 of a gram. So here's the thing. When we take a measurement, we like to get as many digits as possible. So though we can measure to 1/10 of a gram, we can actually get one extra digit. And the reason for that is we can tell a person if our little indicator is between two tick marks. So therefore, when we actually write out our mass using this scale, we can go to 1/100th of a gram. So that 1/100th of a gram will be an estimate. So now we're ready to take our measurement. Notice that the 100-gram block and the 10-gram block are both set to 0. The only thing that's different is the 1-gram slider here. When you look at it, it's just a hair past 0.4 grams. So the last digit that I'm estimating here is a 1. If it had been exactly on that 0.4 gram mark, my measurement would have been 0.40 grams. The last digit is always an estimate. In this slide, I'm measuring the mass of a penny. Once again, you can see that the 100-gram and 10-gram blocks are at 0. When I look at my 1-gram slider, I notice that it appears to be between 3.2 and 3.3. Making an estimate of that last digit, it looks like an 8 to me, so I wrote down the mass as being 3.28 grams. In this slide, I'm measuring the mass of a sphere. When I look at the 10-gram beam, I notice that the block is on the 30 mark. So I have 30 grams. Looking at the 1-gram beam, I notice that my indicator is basically between 1.9 and 2 grams. So my estimate is roughly 1.98 grams. Adding it all together, the total mass of the sphere is 31.98 grams.